Okay, so I'm going to pick up where I left off on the other recording. I'm going to pick up at number seven. So number seven, coming right here, I'm going to just put number seven. It says your point estimate of the average daily caffeine intake for business majors has a mean of 210 milligrams, and the population standard deviation is believed to be 55 milligrams from a prior research. What sample size is needed to achieve maximum margin of error of 10 milligrams at 95% confidence? So what I've got right here are some words that you need to be paying attention to. There's some keywords. Like I said, there are three major keywords or key concepts that you need to be looking for, and that's probability, um, then also whether or not you're dealing with a mean, and then also a proportion. So what you see right here is average daily caffeine. So this right here is a mean. And then we have also sample size is needed. So it's asking what sample size is needed. So coming over here, knowing that we're dealing with a mean, uh, these right here are dealing with a mean. And then it talks about margin of error. So margin of error with a mean. But it's saying the needed sample size. So margin of error, the needed sample size around a mean. So that's coming right here. And so what we need to do is come down here where it says calculate needed sample size for confidence interval around a mean. And we're going to go ahead and do that. Okay, oops. And so I'm going to click on this, 7. So standard deviation or population, whatever, standard deviation, it's going to ask for z-score, max allowable error, and sample size. So first of all, the standard deviation for number seven gives me 55. Okay. The z-score, 95% confident. So the z-score for 95% confidence is going to be 1.96. Okay. The max allowable error is going to say for what is to the maximum allowable error of 10 milligrams. Okay. And so what is the needed sample size? So yeah, right down there, n equals um oops, the z-score multiplied by the standard deviation. And just looking right down here again, divided by the max allowable error, and then we're going to square it. And so the needed sample size says 116.208, but we're going to interpret this and we're going to say to narrow the margin of error or to have a margin of error of 10. Let's see here. Um, we need to have a sample margin of error of 10 around the point estimate of, let's see here, 210 milligrams. We need to have a sample size of 117. Okay, so that's how we do number seven. Going on to number eight. So number eight. A random sample of 45 students shows that 31 used any caffeinated beverages while studying for last night's exam. Construct a 99% confidence interval for the true proportion of students who use caffeine while studying. So looking at this, once again, the keywords that we are looking for, a random sample of 45 students that 30 show that 31 use. So those keywords, is it proportion, mean, and then probability? And then if it is proportion or mean, is it asking for a margin of error or is it looking for a sample size, needed sample size? So This is what we're looking for. Whoops. So number 8. It says to construct a 99% confidence interval. So we are dealing with a confidence interval. So it's going to be somewhere down here on the bottom right hand or the bottom of the page. So something with a confidence interval of a true proportion of students. The way that we can do it is 31 out of 45. That's also a proportion. And so we're making a confidence interval around a proportion is what it says. And so in order to do that, we're going to come right down here, confidence interval around a proportion. So it's 1, 2, 3, 4. So 1, 2, 3, 4, confidence interval around a proportion. Okay. Um, so we're going to proportion, proportion. Okay. Uh, Z-score, MOE, and then CI upper and CI lower. So what is the proportion? The proportion is 31 out of 45. So e equals 31 divided by 45. And then Z, so 99% confident. The Z score for 99% is right here, 2.576. So 2.576. Then what's the margin of error? So we're just going to follow these steps for the margin of error. So we're going to do equals the z-score, which is 2.576, multiplied by the square root of the proportion, okay, and then close the proportion, or close the parentheses, square root of the proportion multiplied by, sorry, no, parentheses, 1 minus the proportion, close parentheses, divided by the sample size, and the sample size is 45. So going back to the original question, so I put this formula in there. I did the z-score, which is 2.576, multiplied by the square root of the proportion multiplied by 1 minus the proportion divided by 45, which is the sample size, which gives me a margin of error of around 17.7%. So what's the upper and lower confidence interval? I take the proportion plus the margin of error. Then I do equals the proportion minus the margin of error. And so now what I can say is I am, let's see here, 99% confident that the actual population proportion of students who use caffeinated beverages during studying is between 51.11% and 86.7%. There we go. So and I'm just going to, here, let's do this. Um, there we go. So you can see the nine. Okay. Speaking of caffeinated beverages, there we go. A dietitian records caffeine milligrams for a convenient sample of 12 energy shots with a mean of 128 milligrams and this right here, S, a sample standard deviation of 22 milligrams. Assume the population standard deviation is unknown. Wow, they were really nice in giving that to you. I'm not going to be that nice. I'm just going to give you the S equals 22. Find the 95% confidence interval for the mean caffeine per shot. Okay, so we're going to come down to number 9. Let's come back up here. What are the key words here? So once again, am I looking for a mean? Well, uh, convenience sample, 12 energy shots. There is a standard deviation. If you have a standard deviation, you're dealing with a mean because the standard deviation is around the mean. So the mean And then am I looking for the confidence interval or a needed sample size? It says finding a 95% confidence interval. And then do I know the population standard deviation or is the population standard deviation unknown? It's unknown. So what I did here, confidence interval around a mean. I'm dealing with making a confidence interval with a margin of error. So I go down to the left-hand side of the chart, and then I go to the population standard deviation unknown, which is the second set of boxes. So we're coming to right here. Okay, so 3, 2, 1, confidence interval around the mean. We don't know the population standard deviation, so we're going to go through this step by step for number 9. Okay, so let me make this so I can actually see it. There we go. So number 9, uh, mean. I know that it has this formula right here. All that this formula is for calculating the mean. You don't have to calculate the mean quite often because I just straight up give you the mean, but there are times where you do have to calculate the mean because I'll give you like raw data. So the mean is 128. And then the degrees of freedom, let's also, so degrees of freedom, t-score, standard error, MOE, and then CI upper, CI lower. Okay. And I'm going to move this down because there's two more things that I want. I want the sample size and I want the standard deviation. So the sample size is, let's see here, 12, because it says 12 energy shots. Standard deviation is 22 milligrams. So the degrees of freedom is the sample size minus 1. So degrees of freedom is the amount of flexibility that you have with your data. And then what is your t-score? So for your t-score, you're going to use this formula right here, t dot inverse dot 2t probability degrees of freedom. So equals t dot inverse dot 2t. And so for the probability, it's going to be 1 minus the amount of confidence that you want. So 95% confident. So 1 minus that is going to be 0.05. And then the degrees of freedom, which is right here. Okay, so degrees of freedom, so now the t-score is 2.2. So to get standard error, we get sampling error, oh no, uh, standard error is standard deviation divided by the square root of n. I was almost calculated something else. Okay, so equals standard deviation divided by square root of the sample size. Okay, so we've got our standard error of 6.35. And then what is our margin of error? Our margin of error is going to be equals t-score. So I'm just following along with rights here. T-score multiplied by the standard error. Okay, so that's our margin of error. So the upper is going to be the mean plus the margin of error. Okay, and then the lower is going to be equals the mean minus the margin of error. Yep. So we've got upper, lower, so on and so forth. Um, yeah. Next, let's go ahead and calculate this, and I'm just going to copy and paste this right here, and then I'm going to modify it. So 95% confident. I am 95% confident that the actual population proportion of uh, the amount of caffeine per shot of something. They oh, per energy shot is between what and what. So is between 114.02 milligrams and 141.98 milligrams. Okay. So this is how we would write the interpretation. Okay, so moving on to number 10. Okay. You previously estimated the proportion of commuters who drink caffeinated soda before 10 a.m. At 35% with a minimum sample size. What is the minimum sample size required to estimate this proportion with a margin of error no more than 0.03 at 95%? Okay, so um, right here, what are the key words? Proportion. Remember, these are the keywords: proportion, mean, or probability. We're doing a proportion. And then once we see that it's a proportion, are we looking for a margin of error or needed sample size? It says we are looking for what is the minimum n. In other words, what's the minimum sample size required to estimate the proportion with a margin of error no more than 0.03. So sample size. So if you come up here, we are doing a confidence interval around a proportion, which is on the right-hand side. And then step two, we're going to needed sample size, which is the very last box. And so let's go back to the last box, three, this one down here in the bottom right-hand corner. Okay. And so I'm going to proportion or proportion MOE, max allowable error, then z-score, and then n. So let's go ahead and fill this in. So for number 10, what is the proportion? That is the previously known proportion. If you don't know the proportion, put it in as 0.5 because that will give you the largest sample size that you need. Okay, so then margin of error or maximum allowable error is what we've got now is going to be 0.03, which you see right here. So 0.03. And then the z-score for 95% confident is going to be 1.96. And then the needed sample size, we're going to put this in, equals the proportion multiplied by, and notice I'm just following along with this, what this says right down here, proportion multiplied by uh, 1 minus the proportion, or 1 minus p. Gosh, I'm trying to click on it. There we go. 1 minus p multiplied by the z-score divided by the max allowable error. And then we're going to square it. So this gives us a needed sample size of 971.07, but we round that up to 972. So if we look at how to interpret this, we're going to say if, or 2b says number 10, 95% confident of uh, the confidence interval um, uh, confidence interval um, for the proportion of commuters who drink soda before 10 a.m. With a max allowable error of 0.03, a sample size of 972 is needed. So there we go. Next, 11. Okay. Suppose the true mean caffeine for extra strength energy drinks is 200 milligrams, and the population standard deviation is 24 milligrams. What is the probability that a single sample n equals 16 has a sample mean of at least 208 milligrams? Okay. So right here, once again, the keywords that we're looking for, uh, proportion, mean, or probability. We see probability right here. So we're dealing with a probability. So if we're dealing with a probability, we're going to go to the formula sheet, and the only place where we're dealing with probability is right here. So we're dealing with probabilities right here, so we're going to calculate the probabilities. So for number 11, we're just going to literally follow along right here with probabilities. So uh, sample mean, pop mean, standard deviation, sample size, degrees of freedom, sampling error, uh, standard error, standard error, z-score, or t-score, and then probability below. So let's go ahead and do this. So for number 11, suppose the true mean caffeine for extra strength energy drink is 200 milligrams. So we're just going to go down from the top and fill it all in. Um, then coming right down here is where we finally see the sample mean. So where do we see the sample mean? Right here. What is the probability of sample of 16 drinks have a sample mean of 200, at least 208 milligrams? So they're saying 208 milligrams or more. Um, and so we're going to do sample mean 208, population mean 200, um, standard deviation, which is right here, so 24. Okay. Sample size is 16. Degrees of freedom is going to be sample size minus 1, so 15, but we don't actually need it for this because we have the population standard deviation. So sampling error is going to be equals sample mean minus population mean. And then standard error is going to be equals standard deviation divided by the square root of the sample size, which the sample size is 16. Okay, and once again, it shows everything over here on the right-hand side of how to do it. Okay, and then what's the z-score? Well, in order to calculate the z-score, I do equals sampling error divided by standard error. Okay, and then what's the probability below this z-score? We're going to do equals norm.s.dist. And then what's the probability above? Is going to be equals 1 minus norm.s.dist. Okay, so let's see here. The question is, what is the probability right here? I'm just gonna, the probability that a random sample of 16 drinks has a sample mean of at least 200 milligrams is, what is it? 9.21%. Okay. And then looking at number 12, the residence hall RA samples 22 students. Weekday caffeine totals with an average, so a sample average of 155 with a sample standard deviation of 48 and at 90% confidence, build an interval for the population mean weekday caffeine among the residents. So right here, it's got a mean. So the keyword there, students weekday with a mean. So that's the keyword right there. And then confidence interval. So we're doing a mean with a confidence interval. And once again, it's got a sample standard deviation. So sample standard deviation means that you're going to be doing a confidence interval around a mean with the population standard deviation unknown. So I'm going to come right over here and I'm going to go to step one, margin of error, confidence interval around a mean, margin of error, and then population standard deviation unknown. And so we're going to be doing this one right here. And so we'll just do that again really quick. Let's see here. So number 12, uh, mean, degrees of freedom, z-score or t-score rather, standard error, margin of error, CI upper, CI lower. And then I'm also going to sample size and standard deviation. So what is the sample size? The sample size, 22 students. Okay, what's the standard deviation? The standard deviation is 48. Oops. Okay, what's the mean? The mean is 155. What's the degrees of freedom? The degrees of freedom is going to be the sample size minus 1, so 21. The t-score, and then we're gonna, to calculate the t-score, we're gonna come right up here So equals t dot inverse dot 2t. So equals t dot inverse dot 2t. Okay, what's the probability? So once again, it's going to be, the probability is going to be whatever the confidence interval is, it's the complement to it. So it's 1 minus the confidence interval, so it's going to be 0.1. And the degrees of freedom is right here, 21. So the t-score is 1.72. Then what's the standard error? That's going to be the standard deviation divided by the square root of n. So equals standard deviation divided by square root of the sample size. Okay, and then the margin of error is going to be t multiplied by the standard error, which, once again, you see that right here, t multiplied by the standard error. So equals t multiplied by the standard error. So what's the upper and lower confidence interval? It's going to be equals the mean plus the margin of error equals the mean minus the margin of error. And so this is the confidence interval, and literally these what's it called? These all follow the same format. So like this question right here, let's see here. Where's the last time that I did this with the t-squared? Yeah, right here. I'm going to just copy and paste this and show you, hey, it's pretty much the exact same explanation. What are we doing? I'm 95% confident that the actual what? Population mean. So population mean of the amount of, let's see, mean of weekday caffeine totals for students is between, so is between 137, oops, it's not letting me click on it. It's freezing up. Well, is between 137 uh and 137.39 and 172.60. There we go. Yeah, I don't know why it's freezing up. Uh there we go. 137.39 milligrams and 172.61 milligrams. Okay. I just want to look at one more thing. Here I put population proportion. I did not mean to put population proportion. I meant to put population mean for this one. So number 9, the explanation should say population mean. I am 95% confident that the actual population mean of the amount that the caffeine per energy shot is between 114. Okay. And then this one, number 10 is proportion. I think I copied from above here and I didn't change it. Okay, so I'm 95% confident that the actual population mean is between 137 and 172. So that's how you would write that up. So that's all of these. I will post all of these questions in to Canvas. And then you guys can work through it with the video and just work through it with the formula sheet as well. The big thing that you guys need to really focus on is once you figure out which step to go to, like which approach to take, stay there. Don't jump around. Like stay there and do that one over and over. Like just stay there for the remainder of that question. So let's see here.